Okay, so now we're going to begin Chapter 11. Chapter 11 begins our graphing information. So this is a line graph. It says the line graph below shows the class averages on the first 8 quizzes in a college math course. So let's see, look, we've got quiz 1 right here, and apparently we're going from 0 to 10 for these scores, and here's a 5, 7.5. Here's quiz 2, okay, all the way to quiz 8. Which quiz had the highest class average? Okay, well, the highest point is right here. So quiz 3 had the highest class average. Which quiz experienced the biggest jump in class average from the previous quiz? Okay, so that looks like right here is the biggest jump. Okay, so quiz 5 was the biggest jump from the previous quiz. Estimate the difference between the class average on quiz 2 and quiz 3. So here's quiz 2, here's quiz 3, and it just says estimate because I don't know. This must be about 7, right? And this one is maybe 9. So 9 minus 7, it's about a 2. Okay, so you've got a couple like that where it's just asking you to interpret and read a couple of graphs. But what we're really interested in is drawing our own graphs. And so right now, let's just get some terminology out of the way. Okay, so our graph is technically a Cartesian coordinate system. It's named after Rene Descartes, who invented this way of using 2 number lines put together to form a grid, and that's all it is. It's 2 number lines. Here's a number line, here's a number line. And so we can also just call it a graph or a coordinate system. Okay, so your x-axis is this horizontal one, and your y-axis is the vertical one. If you have trouble remembering which one is which, think about the fact that you can write a y with a vertical bit to it. So it tells me, oh, it's the one that goes up and down. Whether I write a capital or lowercase or cursive x, it doesn't have a horizontal or a vertical component, but I can draw a y. If I draw a capital Y that has a vertical component to help me remember this one's the y-axis. The origin is right here where the 2 number lines intersect, okay? And just as we mentioned, because this is just 2 number lines, then I could label these like this would be 1. Okay, that I'm not going to put 1 on every tick mark because it'd jam up with this little tiny graph here, but that would be 2. So then this is 3, and then 4, and then 5. Same way over here, this is -1, -2, -3, -4, -5, -6. Okay, and going up, it starts out with 1, and then 2, and then 3, and then 4, and then 5. And going down, -1, -2, -3. Okay, so that means this point where they intersect is right here, and that represents when x is 0 and y is 0. Okay, positive numbers to the right, negatives to the left, positive numbers up, negatives down. So that's 0, 0. Notice how I wrote that. There's three different terms we can use to describe this. We can call it a coordinate, a point, or an ordered pair. Ordered pair is the most descriptive because it tells us that every coordinate on our system has to be a pair, 2 numbers, and they go in order, x first and then y. Point, though, is the shortest word, so usually that's what we use more often, right? So this point right here, okay, this is, I do x first. You always start at the origin. Origin means beginning, right? And I see, well, where is my x value for this line? 1, 2, 3. Oh, x is 3. And what is y? It corresponds right here to y, so that's 1, 2, 3, 4, 5. That is the point 3, 5. It means x is 3 and y is 5 right here on this intersection. If you have your point is actually on an axis, they're called intercepts, right? Intercepts, because they intercept or intersect the line. Okay, the one on the y-axis is the y-intercept, and it has a number in the y. The x is always going to be 0, because this point is to get to it. If I start at the beginning, at the origin, I don't go right or left at all. So that's a 0, but I went up 1, 2, 3 on the y-axis. Okay, this point over here, when I start at the origin, I go left 1, 2, 3, 4, 5, 6, so that's -6. But then I don't go up or down at all, so the y is 0. So your x-intercept has a number for x. Y is 0. Your y-intercept has a number for y. Okay? Now, these two number lines break this grid up into 4 sections. And those are called quadrants, because quad means 4. This one right here is your first quadrant, and then you go counterclockwise. So this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, everything in the first quadrant is positive. Notice that's a +3 and a +5, because to be in the first quadrant, you go positive, positive. Okay, in the second quadrant, the x's are negative and the y's are positive, because you would have to go negative, positive to get up in this quadrant. Here, they're both negative. Negative in the x direction, negative in the y direction would put you in the third quadrant. And in the fourth quadrant, x is positive, y is negative. Okay. If you have a question that asks you which quadrant this point is on, they're just trying to be tricky. If your point is an intercept, it's not in any quadrant, right? It is not in a quadrant if it's on an axis. Okay, plot each ordered pair on a coordinate system. All right, so let's see if I can match those colors a little bit. A, x is 1, y is 5. So if x is 1, I go over 1, and then y is 5. There's where that point would be. Okay. B, x is -2, y is 3. C, I'll try. C, okay, x is -1, y is -4. You just always go back and you start at the origin or the beginning. I don't have a brown, so I'm going to use black for this one. And then you do the x first. You go back and forth first, and then up and down. So over 3, down 2. Oh, I also don't have a pink. So let's use yellow. Okay, so 3/2, I may have to change that to a mixed number. So this is really 1.5, 2. So you just go over 1.5 and then up 2. Okay, 5, 0, 1, 2, 3, 4, 5, and then you don't go up or down at all. So that is my x-intercept. And then 0, -3, I don't go up or down. I don't go right or left. I only go down 3. That is my y-intercept. Okay, so plotting points. Start at the beginning, at the origin. Do your x direction first, so right or left, and then y, up or down. Okay. So why we're talking about this now, these are going to be our solutions to an equation. Okay, so the first thing we're going to do is just try to decide if an ordered pair is a solution for an equation. Remember what this means. The order matters. So the first one is x, the second one is y. And if I want to know if that's a solution to this equation, all I have to do is plug it in and see if it makes it true. So I'm going to rewrite it, except when I get an x, I'm going to replace it with 2 because it says x is 2 right here. Minus 2, but instead of y, we're going to replace it with that 3. And then my question is that true? If it is, then the 0.23 is a solution to that equation. If it's not, the 0.23 is not a solution. So that's 10 minus 6 equals 4. That is true. Yes, this is a solution to the equation. Let's see if -2, -3 is. Okay, so I'm going to let x be -2 and y be -3. And my question is, does that equal 4 also? So is -10 plus 6 equal to 4? No, it does not equal 4. Okay, so then we need to be able to complete ordered pairs. Okay, so that means I know that x is 3. I need to find out what y is when x is 3. So I'm going to plug that 3 into the equation. And then that just gives me one variable so I can solve it. So 6 minus y equals 6. Let's subtract 6 from both sides. Oh, so negative y equals 0. Divide by -1. So y equals 0. Okay. This one says when y is 1, what's x? So let's plug that in. 2x minus 1 equals 6. And let's solve that equation for x. So let's add 1 to both sides. So 2x equals 7. Divide by 2. X equals 7/2. So when y is 1, x is 7/2. So the way typically when we're talking about graphing, the typical way we represent finding these points is with a table of values. Okay, but this is asking us the exact same thing that previous question did. It's just putting the values here. So it's like this. Notice here's the x's, here's the y's, and this, right, where we're trying to fill in the y here and the x here. Okay, but this is how we're going to see it now from now on. Okay, so again, this is saying, well, if y is -1, what is x? So let's plug a -1 in there for y and solve this equation. -3 times -1 is a +3. And so if I subtract 3 from both sides, I get x is 3. Okay. Same thing, except this time it's given me the x value. So plug it in for x. 12 minus 3y equals 6 equals, subtract 12 from both sides, minus 3y equals negative 6, divide by negative 3, just solving an equation. So y equals 2 when x equals 12. Okay, and last thing, we're really not going to be given any values. And so we have to find some values, and we'll make our own. This is called a T-bar, a T-chart, a T-diagram. Notice the big T. But we'll have our X column and our Y column. Okay, and so I can make up any numbers I want. Well, let's see what happens if X is 5, right? And then find the corresponding one. Let's see. Let's plug in a 5 for X. So 15 minus 4y equals 12. Divide by 15. Not divide by 15. What am I doing? I'm sorry, my dog distracted me, guys. I was sorry. Okay. He's been silly. Okay, subtract 15. Okay, so minus 4y equals negative 3, and divide by negative 4. So y equals 3/4 if x is 5. Okay, so we could do that all day long and just pick different numbers and see the different combinations. But think about this. What if I plugged in and let x be 0? All right, so that means 3 times 0 minus 4y equals 12. Oh, that's gone if that's 0. So all I have to do is that one-step problem instead of look at all of this. So y is negative 3. Another easy number to find when we're finding our own is let y equal 0 then. Think about that. If y is 0, if I use the intercepts for points I'm finding, then I really don't have to do any math. If y is 0, that's gone, right? Negative 4 times 0 is 0. And then all I have to do is divide both sides by 3, or say 3 times what equals 12. And look how easily I can get those points. So I want to remember this when I need 2 points. Those intercepts are way easy points to find, way easier than this. And look, this is even, I wound up with a fraction. Okay, so we're going to practice that first, and then when we come back, maybe we'll put all this together.